In this video, we are going to go over integers. Integers are a fundamental data type in Python used to represent whole numbers. They encompass positive, negative, and zero values without any decimals or fractional parts. They are utilized in various computational tasks ranging from simple counting to complex mathematical calculations. Python's integer data type can accommodate a wide range of whole numbers from very small to very, very large. Common uses for integers are counting and indexing. Integers are essential in counting iterations and indexing elements within data structures like lists, tuples, and strings. They are used in mathematical calculations and often used for constructing algorithms and solving numeric problems. And integers are used in control structures. Integers play a key role in conditionals, loops, and decision-making, allowing programs to respond dynamically based on numeric values. There are a couple of ways to create integers. The easiest way is to simply create a variable and use the equal sign to assign it a whole number value, such as my_int equals 5. You can also create integers by using the int function, and you can pass different values into the int function and it will attempt to convert it to an integer. So if I pass in the value 5.3 and then I print my_int and run this, we'll see that I get the output of 5 with the decimal part removed. You can also pass a string representation of an integer value into the int function, such as 123. And if I run this now, we'll get the output 123. However, if I tried to pass in the string representation of a float value into the int function and run this, it will raise an error. I get a value error that it's an invalid literal for int with base 10. So try to remember, if you do use the int function with a string value, that it is a whole number with no decimal or fractional parts. You can use common arithmetic operations with integers, such as myInt equals 10 plus 35. And if I run this, we'll get the output 45 down here. Or if I did something like 25 minus 24 and run that, I'll get the output 1. And unlike floating point numbers, which we will look at in an upcoming video, Python does not have any limitations with integer values. So I could have these two variables x and y that have these extremely large integer values here. And if I try to output either one of these, it works just fine. It outputs it with no issues at all. And I can even add these together by doing x plus y. And if I run this again, we'll see that it added these two very large integers together just fine. Now I want to show you some built-in functions that Python provides to work with numeric values. So I'm going to go ahead and remove this code here, and I am going to create a result variable, and I will set it to equal ABS. And in ABS, I will pass -12. So this is the absolute value function. It returns the absolute value of the argument. And what the absolute value is essentially the positive value of a numerical argument. So here I am passing in a -12, but when I print the value of result, it will output a positive 12 down here, and we can see that right here. The next function I will show you is the min function, and that is just min. And in the min function, we can pass a group of variables separated by a comma. And what the min function does is it returns the smallest item. We can see here it says with a single iterable argument. So if we pass in like a list or a tuple, it returns the smallest item. With 2 or more arguments, it returns the smallest argument. So here I am passing in 4 arguments separated by a comma. And when I run this, it is going to return the 1 because the 1 is the smallest item. So down here, we get this output of the 1. And I can also pass a list into here. And if I put in some square brackets, I can put in a list of numbers here. And if I run this, it is going to output 21 because 21 is the smallest number in this list. So down here, I get 21. And there's also a max function, which returns the maximum number in the arguments or the list. So this time when I run it with the max function, it is going to return the 27. And when I run that, we'll see that we get this 27 down here in the terminal. Python also has a built-in sum function. So if I replace this max function with the sum function and hover over it, it says it returns the sum of a start value plus an iterable of numbers. What this means is that I could provide a start value and then it would add these numbers to that start value. Or if I just pass in the iterable, it will simply get the sum of the numbers in the iterable. So when I run this here, we'll get 71, which is the sum of 23, 21, and 27. And I could add a start value here, such as 10, and it would add all these numbers here to this value 10. And when I run this, I get the output of 81. The next function is the pow function. So I will put in POW and a set of parentheses. And when I hover over this, it says the equivalent to base asterisk asterisk exponent with 2 arguments, or base asterisk asterisk exponent, and then the percent symbol, and then mod with 3 arguments. And what this means is that if I do 5, 3, 5 is my base, 3 is my exponent, and it is going to raise 5 to the power of 3 and return that value into the result variable. So when I run this, I get the output of 125. And if I add a third argument, it would return the remainder of this value here divided by that third argument. So if I pass in the value of 17 here and run this, I get the output of 6. 125 divided by 17 is 7 with a remainder of 6. So that's where we get this 6 from, is the remainder. And finally, I want to show you the divmod function. With the divmod function, you can pass in 2 arguments, and it is going to return the floor division of the first argument divided by the second argument, so the whole number. And then it is also going to return the remainder of the first argument divided by the second argument. So if I pass in a 26 and a 7 separated by a comma and run this, we are going to get the output 3 and 5. And 26 divided by 7 is 3 with a remainder of 5. And that is where we get this tuple here, which is denoted by the parentheses on either side of these numbers. And in upcoming videos, we will go over more ways to perform arithmetic operations, and I will cover lists and tuples and anything else that I may have discussed in this video.